Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one interesting MCQ. I request everyone please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now look at the reaction. It's actually typically the stepwise hydrogenation of benzene into cyclohexane. Now in this case, the question is about the activation energy. Means the relation among three activation energies E1, E2 and E3 of this above reaction. So this order you need to say. By the way student, this question is a little different type. So in order to go into the main topic, let's learn what activation energy actually is. In Arrhenius model, the activation energy is the amount of energy must be available for a reactant for a chemical reaction to occur. Means a minimum energy needed for a reaction to take place. Means you need to supply this much energy. By the way, it doesn't mean that okay, it will decide it will be exothermic or endothermic. No, it will not decide, but this much energy you need to supply externally such that reaction should take place, and ultimately you will get this energy back. You can look at here. So it's a typical example, alkene and hydrogen. This much EA is your activation energy. You need to supply this much amount of energy to initiate the reaction, but when the reaction complete, this much amount of energy comes out. So it is your investment. You will get it when the product will be formed. So that's why at the beginning of any reaction you need to supply some amount of energy, but when some amount of reaction happen, this much energy produced again, and this released energy act as activation energy for other molecules. If you look at here, in case of benzene, means what reaction actually happening? It is, you may say, sir, stepwise hydrogenation of each of the pi bond, and ultimately it results alkene. So what's happening? Alkene, or you may say, sir, C double bond C reacting with hydrogen to produce this hydrogen addition product. And this reaction is generally exothermic in nature, means this is actually negative. Why? Because in this case the pi bond is broken. Actually here one pi bond broken and hydrogen sigma bond broken, and in product two CH sigma bonds are produced. And we know sigma bond is stronger than pi bond, so that's why this reaction releases energy, or it is exothermic. And that, remember the statement, the higher the stability of double bond, higher the energy of activation. Why? If your alkene is stable means lower in energy, so obviously alkene energy will be lower because this is energy axis. So obviously energy of activation is expected to be higher. In this case you may think, sir, energy release right now it is means delta G will be less, means it is less exothermic. Okay, this is the main concept. Now if you look at here, this aromatic ring is actually, student, stable, because we know these three pi bonds, they are in resonance, delocalization, which we technically called as aromaticity. And remember, aromaticity means stability. Obviously for the first step, the energy of activation will be the highest, E1 will be the highest. Now next place, there is a conjugated double bond that is gone. So okay, next position is this one, and the least one will be this. So this is actually the order. So in which option this is given? E1 is maximum. In which option E1 maximum? Yes, E1, E2, E3. So this is the order. So this will be your right answer. Now if you get this question in your exam or less than 30 seconds, how would you get? Remember, benzene, aromatic, very stable molecule. So this case the energy of activation will be the highest among three. In which option E1 has the highest value? See, option D only. So if you follow this much common sense, then you can get the right answer less than 30 seconds. But I always believe that you should know it completely. So in conclusion, what have we learned? Hydrogenation reaction is generally exothermic, as I told, pi bonds to sigma bond. Extent of energy release depends on the stability of alkene, the gap, and the alkene. In this case, there is a product. Here, the energy of activation for more stable compound is generally higher, means reactant is more stable. And finally, the aromatic compounds are very stable due to higher delocalization of pi electron density, means resonance is very large. Here the reaction involves a loss of resonance energy. That's why activation energy is very, means if you go from here to here, this is aromatic, stable to less stable. If you want to go, you need to supply large amount of energy externally, then only you can have it. So if this energy requirement is more, obviously energy of activation is always be more for this process. Similar kind of thing you may expect for aromatic electrophilic substitution, first step sigma complex formation. Okay, so this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.